Hello students, welcome in our class. So in the last two lectures, I have discussed some questions which are based on my research actually. But in today's class, I am going to share you about new research of my research obviously. But this research is related to your topic only. You already see here the topic which is code of Pythagoras theorem, which is code of Pythagoras theorem. Okay, so what we will observe here that you all know, first of all, I going from basics of course, I have taken the word here code, and you know that code means not take don't take it the coding language, because today's generation, today's technology are all because of computer science, and in the computer science subjects coding is very important. Most of the students in their engineering courses, they always try to take the computer science courses. They want to learn programming, they want to learn coding, and coding is developing the world more modernly. But we are not talking about the coding here. Code means some words which has different meaning. For example, you know that Tiger 3 has released now, and in the life of a spy agent, you very well know that they use some different types of words. For example, if they want to talk about this man, they will not take his name directly to other agent, but they will use some words, some other name, so that like a code for them, like a code. So some code basically means some. I think you understand very well. Code generally means some meaning is there. It is a word. It is something like to understand something. It has some secrets. Code has some secrets, right? Code has some secrets, and that secret thing I am going to tell you, which will very helpful while solving the Pythagoras theorem, while solving the magnitude of a force, because this Pythagoras theorem is very important in physics to find the magnitude of the force, magnitude of stress, all these things. So we will discuss one by one. Let us go into it. I will not take much time of yours. So as usual, we will first discuss the contents present in the slide. So number one is multiplication of standard Pythagoras theorem. This topic is not coming in our topic, but if you know it very well, then it's all good. If you don't know, let us tell you. Let us go into it. It is a other topic, but the second topic is code of Pythagoras triplet. The second topic is code of Pythagorean triplet. Here, what we will do, we will talk about the first Pythagorean triplet, and then we will talk about the standard Pythagorean triplet, and from that Pythagorean triplet we will understand what code we are going to learn here, what code actually we are going to learn here. Okay, so the first topic is a other topic which I want to tell you that topic, how it helps. Then next is table of Pythagorean codes or Pythagoras codes. After learning the code, we will construct a table, and that will be a standard table. We will discuss all, and from that table we have some observations. From that table we have some observations, and last we will do some problems, and we will discuss some advantages and disadvantages, like if you're doing one experiment, then how much it is beneficial and how much it is not beneficial. We can talk in terms of advantages and disadvantages. Same way, as this is a research, as this is one kind of research, we will discuss some advantages and disadvantages, how much it is advantageous and how much it is not disadvantageous. So basing on the observations only, we can predict these advantages and disadvantages, but research may be going on later on in the future, and we may get more advantage, more disadvantage we will may have. But up to now, whatever advantages and disadvantages we got now till that we will discuss. Okay, let's go. So talk as I tell you earlier, first we will discuss multiplication of standard Pythagorean triplet. Okay, now I will take an example. Okay, this is one Pythagorean triplet. Now Pythagorean triplet means what? What do you mean Pythagorean triplet? Let us write down the definition once. From 8th class to any class or any education you are taking, you can take anyone. Anyone can see this lecture. It is not restricted that only class 11 students will see, class 12 students only will see. That's not here. Pythagorean triplet means a triplet of integers which follows Pythagoras theorem. Which follows the Pythagoras theorem is called a Pythagorean triplet. As I told you the example 3, 4, 5. So this is the Pythagorean triplet. Of course my handwriting is not good, but I think you better understand because I'm also dictating the things. So triplet means three numbers A, B, C. Triplet means three numbers, and if these three numbers follows the rule, this one, there are three numbers which is called a triplet, and such that c square is equal to a square plus b square, or c is equal to root over a square plus b square, then this is called a Pythagorean triplet. But in Pythagorean triplet, there is coming two terms. One is standard Pythagorean triplet. Shortly I am writing PT, standard Pythagorean triplet, and another is multiple of standard Pythagorean triplet. So we have divided this Pythagorean triplet as per the research in two topics, in two parts. One is standard Pythagorean triplet, another is the multiple of standard Pythagorean triplet. So let us talk about first standard Pythagorean triplet. So standard Pythagorean triplet, what does it mean? What is mean by standard Pythagorean triplet? If triplet has only one HCF or multiplied by only one number that is 1, then it is called standard Pythagorean triplet. Okay, see, understand this. If the triplet has only one HCF, means one highest common factor, or multiplied by only one number, which number is 1, then it is called, this is I, okay, it is called the standard Pythagorean triplet. Understand? First time starting with the definitions. After that I will go to the uh, what we say, I will go to the mechanism of this statement. Okay, I think you written, or you can take screenshot and write down, no problem. Next one is multiplication of standard Pythagorean triplet. If the standard Pythagorean triplet is multiplied by an integer, then that new triplet is called multiplied standard Pythagorean triplet, in short SPT. So if the standard Pythagorean triplet is multiplied by an integer, this is an integer, then that new triplet is called multiplied SPT. Okay, so I think you written these two definitions. Now let us talk one by one. Now consider two triplet. One is 3, 4, 5, and another one is 6, 8, 10. And now I am trying to find the common factor, highest common factor, 3, 4, 5. You see, only one is possible to factorize these three. So it is only multiplied with 1. And if you see 6, 8, 10, you know these two are Pythagorean triplet. So these are divisible by 2. You will get 3, 4, 5. So this 3, 4, 5 is what? A standard Pythagorean triplet. Because after that only one can possible to divide this. Okay. So what did you observe? What did you observe here? That this is equal to 2 into understand this, that 2 into bracket I have given, and that means this 2 is multiplying in all the elements. Suppose 3 into 3, 1, 2, 5, like this if I am giving you, so it is multiplying, that means the result will be what? 9, 3, 6, 15. All entire elements present in the bracket should be multiplied. Okay, so Oh yeah. Okay, that's all erased. Oh, wait. So if I multiplied 3, 4, 5 with 2, I get 6, 8, 10. If I multiplying this 3, 4, 5 with 3, I will get 9, 12, 15. And now let us check this is a Pythagorean triplet or not. So 9 square plus 12 square root over, that is 81 plus 144. You will get 225 if you add it, and this is what 15 square, so we get 15. Okay, so it is a Pythagorean triplet. Okay, similarly, if I multiply this 3, 4, 5 with 11, let us take some big number. The result will be what? 33, 44 and 55. Now we will check this one also, whether it is a Pythagorean triplet or not. 33 square plus 44 square whole root. So uh, if you calculate and add, you will get what? Wait a minute. You will get root over 3025. And you will get 55. So what is the mechanism of this? Why it has to come like this? Okay, so that mechanism we will talk about here now. Now I will take this third example. Okay, now I will take the third example. So I will go in the reverse method to give you the result. Now we see that 33 square plus 44 square is equal to 55, we have shown. So now this 33 can be written as 11 into 3 plus 11 into 4 whole square, and same way I can write 11 into 5. And now you well known that AB square is equal to A square into B square, so we can split. Okay, we can split it. Now 11 square into 3 square plus 11 square into 4 square under root is 11 into 5. Next I can take 11 square common, then I have left with root over 3 square plus 4 square, and here I left with 11 into 5, and this 11 square whole root 11 get cancelled. You will get what? So in the reverse method, alternatively, this one is a true. We know that this is a Pythagorean triplet, and we have converted into this standard Pythagorean triplet. We have what we have done, we have converted into the standard Pythagorean triplet. Okay, So that's why it is the topic we have first discussed, multiplication of standard Pythagorean triplet. Similarly, let us take another standard Pythagorean triplet, which is let's take 5 comma 12 comma 13. I am taking 5 comma 12 comma 13. It's a standard because if you factorize it, you will get only 1. It can only be multiplied by 1 only. Okay. Oh, wait, again I'm writing. If I multiply, suppose with 2, I will get 10 comma 24 comma 26, and now I will check it. 10 square plus 24 square whole root 100 plus 576 is 676, which is 26, I guess so. Yes. Okay. So this is the mechanism. This is the this is the rule, that this is also a Pythagorean triplet, but it's a multiplication of standard Pythagorean triplet. And you already know the mechanism, just I have discussed with you. Okay. So, and now you see here, everything I've discussed is written here. You know perfectly that 3, 4, 5 is the Pythagorean triplet. Why? You know, I have discussed this one. Okay, one bracket is left here. Okay. And also this one, the question asking why, and I have given you the result why, and this is the reason. These are the multiples of standard Pythagorean triplet. Here this, it's the multiplication of this 3 comma 4 comma 5. So this is the actually note. It is the actual, like a theorem, you say it's like a theorem, but we cannot say it's a theorem. Just you note it down. If you multiply any integer to the standard Pythagorean triplet, example 3, 4, 5, the new multiplier triplet is also a Pythagorean triplet. So this is what? So this is the mechanism. This is the statement. Okay, this is the statement. Now, some of the standard Pythagorean triplet are stated below. One is 3, 4, 5, 5, 12, 13. This is also, you see here, only one is the highest common factor. This fourth one is not here. Let us erase it. Sorry. Okay. Let us try to multiply each triplet by 1.523 and check whether they are Pythagorean triplet or not. So this task we have already done, but let us again we do one with 1.5. I have not talked with the decimal. Even decimal can also be possible. So that means not integer, any rational number, we say any rational number can be possible. See, you will get 4.5, 6 and 7.5. Now we got 4.5, 6, 7.5. Same method. Let us check it. If you solve it, what you will get? You will get 56.25. If you root over it, you will get 7.5. I have written directly. We can use your own calculations and try to find it. Okay, this is 4. So similar way, try to find these two also using 1.5, 2 and 3. Okay, so this is all about the first topic, multiplication of standard Pythagorean triplet. Now we will use this Pythagorean triplet and we will derive one code for which this lecture is taken here. So now we will discuss about the code of Pythagorean triplet. So let us first discuss in short. Uh, I have discussed with you that 3 square plus 4 square under root you will get 5. Right? I have discussed this one. Even I have discussed this one, 33 square plus 44 square is also equal to 55. Now I will tell you that take any two numbers of 2 digit where it will be starting with 3 and 4 only, but you have to take small numbers first. So I will take suppose here 1 and here 3, and now what we will find that 31 square uh, plus 43 square, if you try to find it, you will get about 53. Okay, even if I take 3-digit number, starting with 3 and 4, let us take 312, 415 and try to find out same way. You will get 519.9. Okay, let me clear it. 519.2. Okay, okay, 519.2. So what do you observe here? So we have here two observations. You see, first I underline this and you can observe it. Let us take another color to underline. So the first underline indicates that in each of the case you see the highest place value digit number. In every example we have taken the highest place value digit number is 3 and 4. We are starting with 3 and 4, and in the final result we are getting 5 as the final digit number only. So I can write it like this, that if my base is 3, my hypotenuse is 4, my result will always be 5. Or I can write, if my base is 4, perpendicular is 3, this is perpendicular, hypotenuse I have spoken wrongly, then I will get 5. Okay, so this is one kind of code. Okay, similarly this is only the code. Okay, suppose if I take 7 and 24, or 24 and 7, if I take, I will get here 25 and here also 25. Okay, so this is one the code. So here we will discuss one more thing about the digits, and we will introduce one term called equivalent digits. This term is given as per the research. Equivalent digits, you see here, let us take another color. Here one digit, here one digit, here you got one digit, here two digit, here also two digit, here two digit, here three digit, here three digit, result also having three digit, and the decimal part we are ignoring because we are not dealing with the decimal part. You can observe the decimal point is coming after the same number of digits. So everywhere after the highest place value digit, so let us erase all. Everywhere if I taking 3, 4, and I know that I will get 5, if I take one digit, here also I have to take one digit, so then only my 5 can come. To getting this result 5, in the highest place value digit, in the high, this is, suppose this is 3 digit, this is 1 digit, this is 10th digit, and this is 100th digit, and now 100 digit is the highest place value, right, place value digit. So to getting this 5, to my, according to my code, 3, 4, you get 5, right? So to getting this 5, in, if I taking after 3 one digit, I will take 4, I will take one digit. So net digits how much? Here 2 digit, here 2 digit. If I take after 3 2 digits, to getting this 5, after 4 also I have to take 2 digits, then only you can get 5. So what happens if you not focus on the digits? So I will take one example. Suppose I have taken 31 and another one 4, so I have not taken any digit after 4. So you see, as 31 is very much dominating, as you see 31 is very much greater than 4, because you see the difference is what, 27 is also very much greater than 4. So 31 is very much dominating, and if you find out its square root, you will get some 31 point something. Let us tell you now. 31.25. Okay, 31.25, that is not bar, 25 only. Oh sorry, oh sorry, uh mistakenly I have erased all. I think you understand it now. 31 square plus 4 square, you are getting 31.25. So because of unequivalent digits, you are getting 31 but not 5, not equal to 5 dash point something, you are not getting. Okay, so now taking another example similar way. See here another example with you. 7 square plus 24 square is equal to 25. Oh wait, some technical issues are coming. 25. Okay, so if I take after 7 one digit to getting 25, I have to take after 24 one digit, and you keep remember that to getting 25, this 24 must be there. This 24 must be there. It must be there present. Otherwise, you cannot get 24. I mean 25. So net digits how much here? 2. 2 digits. And here net digits are 3 digits. So this is the concept of equivalent digits as prescribed here. I mean described here. Okay. So I will tell you this how. Suppose I have taken 72 square and 241 square. So what you will get? See. You will get 251 and 52. But you see 24 is very much greater than 7. 24 is very much greater than 7, or we say 24 is greater than 7, so the resultant will also have highest number of digits. One more point you add it. If two numbers are of unequal digits, the resultant will have the highest digit numbers. I mean to say that the resultant number which we will get, its digits will be equal to the digits of the highest number in the two numbers. Okay, so here you have two numbers, so that's why here two numbers. Here you have three numbers, so that's why you have three numbers. But as you see, this 7, this 24 I have kept here, that's why 25. If suppose mistakenly I have replaces this 4 by any other number. Suppose 7 1 square I have taken, but instead of 24 I will take 231 square. So here 4 is replaced by 3. So what will you get? You are getting 24, 241 or 242, you say. I am taking round up value just to see. It follows this rule that highest digit number will give highest digit result, highest digits of result. But as you see, I have replaced this 3 from 4. My 5 here also replaced by 4. Similarly, if I take 71 square plus 254 square, okay, just taking random examples to make you understand, you will get 264. Okay, round up figure है 264. So it also follows the highest digit number gives highest digit result. But as you see, I have replaced here 4 by 5. My 5 is also replaced by 6. So these are the problems we'll create if you not follow the equivalent digits. So some rules are there. If 7 okay, if 7 square plus 24 square is equal to 25 under root, then these two should must be in the highest place value HPV. These two should be in the highest place value, and after that you should put equivalent digits. Equivalent digits you should follow. So this is the concept behind this. Okay, this is the concept behind the code. Okay, so see, explained everything. This is oh wait, this is I explained you. This one also and this one also. I taken 53.01. Actually it's going to be get 53. Okay, so again one example 3747. You see here 3, 4 and 5 you get, and if you take 3 digit numbers also you getting same result. So what do you observe? This is the reason. We observe that in the number of highest place value digit, that is 3 and 4, then in the highest place value digit of the resultant number we get 5, which is the hypotenuse of sides 3, 4. Because I am talking about Pythagoras theorem, so we will say 5 is the hypotenuse of 3 and 4. So, okay, so this observation we can call as code of Pythagoras theorem. So similarly here another example I discussed this one, 71 square plus 241 square. I have talked you that this 7 and 24 must be there for making equivalent digits rule. Okay, I have marked red here so you can understand this. So for your understanding I am erasing this and you can take the screenshot. I think now you have taken the screenshot. So now we make a table and understand the concept more deeply. Now as I make a small table like this, right? This is 3, 4, 5 or 4, 3, 5. This like this table I have created in the explanation part. And similarly, one table is constructed. Okay, so next topic is table of Pythagoras chords. Now we can say chords of Pythagoras theorem or Pythagoras chords, same meaning, doesn't bother about it. I mean, don't bother about it. So see, this is the table. So it will take some time to explain this table. So see what it means. You see here written base, here written perpendiculars, here written base, they are written perpendiculars, and the construction of table is like that. This is base, this is perpendicular, then this should be hypotenuse. Okay, this is the direction. Perpendicular in this direction, base in this direction, and hypotenuse going in all direction. Hypotenuse in all directions is going. Okay. Now you see, uh, okay, in 0 and 0, if my base is 0 and my perpendicular is 0, so what we will get? 0 square plus 0 square under root, we will get 0 only. So I have written 0, and 0 and 1 if you take, you will get what? 1 only. 0 and 2 if you take, you will get 2 only. So this is the case. Likewise, if you take 0 as the base and all these numbers from 0 to 10, this is not up to 10, there are more. You can have 11, also have 12, also have 13, 14, many are there. You can go as much as you like, but up to now we have taken this much. So likewise, if you take base as 0 and these from 0 to 10 as perpendiculars, this trend which is going here, let me highlight it better. It should be highlighted. Let me highlight it. Oh, sorry. If you take 0 as the base and these all are as your perpendiculars, then oh sorry, then this is the sorry, wait wait just a minute. Then these are your hypotenuse, these are your hypotenuse. So this is one type. Otherwise, if you take perpendicular 0, this 0 you take perpendicular and take these all, wait, from this 0 to 10 you take your base, then these all uh, these all will be your hypotenuse. Okay, these all will be your hypotenuse. Okay, and if you observe both the table, see both the table, if you'll observe that in going downward direction and in going rightward direction, the trend is going equal. The trend is going equal. So we can see that this is symmetrical. And if you observe the table clearly, you will see, yeah, this is the diagonal. This is a 10 by 10 table. It is a 10 by not 10, 11 by 11 table because 0 is included. This is a 11 by 11 table, and you can see that about the diagonal, this part and this part are symmetrical. Okay, that part and this part and this part are symmetrical. Okay, so likewise I have taken example of 0. So this is the one thing, and now I will talk about 1. Let us talk about 1. So this is the 1. If you take 1 and 0, obviously you will get 1. If you take 1 and 1, so 1 square plus 1 square, if you solve it, you will get 1.41. And what is my highest place value number? Only one digit, one place only there, which is 1. So that's why it is written here 1. If I take 1 and 3, suppose, if I take 1 and 3, so I replace, let us clear it. One square plus 3 square. So what we will get? You will get what? You will get 3.16 something. But I already told you that we are not dealing with the decimals, but we will see the decimal is coming after how many digits. So this decimal point is coming after one digit, and one digit is itself is only the highest place value here. So we will get here 3. Similarly, if you take 1 and 5, you will get 5. 1 and 7, you will get 7. 1 and 8, you will get 8. So just observe here and here. Okay, just observe this direction. First observe this direction and then observe from this direction. The arrow marks I have showing you the step to observe the table. The table which is constructed, you should observe it. Okay, now uh, so let us take you to the 2 number. Number 2. Now observe 2 from the base and 2 from the perpendicular. Let us go this direction, this direction, and this is my 2. I have reached to 3. Why 3 coming? Same method. You apply 2 square plus 2 square root, you will get what? you will get 2.8, but here written 3 because after decimal we are observing. Some cases I have told you that we are not dealing with decimal, but if the decimal after decimal value, if the number is very much high, more than 5, then you have to round up the figure and you take 3. So why it is doing so? So because the reason I will tell you here. So let us take here over. So I take 2 square plus 2 square, we get 2.82 I think, and I have round up to 3. If you take like as I explained you, 21 square plus 23 square, if you take, so if you calculate and find, you will get 31.14. You will get 31.14, and here highest place value is 2, 2, and here it is 3. Here it is 3. So that's why we have round up the 3, because when we taking the highest, some big numbers of equivalent digits, every case I'm talking about this equivalent digits. If you talk about the equivalent digits in every case, then we are getting 3. Similarly, let us take 3 square plus 3 square. You will get what? 4.24. And you see it will equivalent to 4 only. Okay, so no need to write this one, because here after decimal is a small number. Similarly, if I suppose say 33 square plus 35 square of equivalent digits, I will get 48.10, and you see the highest place value is 4. Okay, so suppose if I take 4, yeah, you to will get the 5 actually. If you take here also 4, 55.8. Okay, that's the thing. If you take 4 square plus 4 square, you will get what? 5.6. But this one is round up to 6, as because you see 41 square plus 42 square, if I take, what is my root? Uh, okay, it's coming 58.69. Okay, that's okay. I think you can take 5 also. 5 is the answer. I think I'm confused here, but we will see the table.